2.6 Multiplexing and Demultiplexing. Well, if you still recall the end bill example, end kids sending to bill kids example. End is the multiplexer and bill there is the demultiplexer. Right? So if we focus on this example below, so this guy in the middle is a big server machine. There are multiple processes running. You see here, P1 is sending a message out. P2 is also sending a message out. Yeah, the transport layer at the server is doing this, multiplexing. So this host here, from P1 and P2's point of view, generating this message, okay, is the sender. Okay, so sender. So it handles data from multiple sockets or data from multiple processes. Add the transport layer header. So add a little bit more information on top of these packets. Okay. And so therefore later they can be used for the demuxing purpose. So when messages go out and reaching P3 and P4, and P3, P4 in return generates something back as it arrives back to the server at the transport layer. Yeah, transport layer of the server is going to be working as a multiplexer at the receiving side. And what it does is to look into the header, okay, in these packets and then decide whether it should be this socket, the message being forwarded to, or this other socket, the message being forwarded to. Right? So very simplistic, but very important functionality. Now back to the lecture. If you think about it a bit more, multiplexing and demultiplexing, which one is more trivial and which one is less? Yeah, multiplexing, just collect the letters and shuffle it into the mailbox, right? No brainer. But mailman will have to, Bill will have to look at the envelope and see who the envelope is addressed to. So demultiplexing there is less trivial. Similarly, on the internet, the transport layer services receiver also needs additional information, just like the names on the envelope, to do demultiplexing. So the information the receiver side of the transport layer service relies on are these. Okay, the source destination IP addresses and the source and destination port number. Now, let me explain. The host that's receiving a packet, it's going to see this, the IP datagram at the network level. Okay, not quite yet at the transport layer. We are now at the network layer, the receiver's network layer. So what we're seeing there is a packet that we call the IP datagram. So let's call this the datagram. Okay. So now a datagram is composed of the header part and the payload, the data part. Okay, so a header here and data here. Inside the header, there are these fields, the source and the destination IP addresses. Okay, so these information are kept there. So it's a network layer information. And each datagram also carries a transport layer segment, which is this, the data part of the IP datagram. So this here is exactly what's depicted on the side here. It's a segment. Similar to datagram, a segment is also composed of two parts, the headers and the data part. Okay. So the segment's header contains source and the destination port number as well. Right? So source, destination IP together with source, destination port number, they are the information to allow the transport layer services the receiver side to do demultiplexing. Okay, I hope this is clear. And the first form of demultiplexing is called the connectionless demultiplexing. And this is also the kind of demultiplexing being carried out by a UDP connection. All right. So in this type of demultiplexing, we rely only on the destination IP address and destination port number to decide which socket to pass a packet towards. So it's only a two-element tuple. Right? So when a host receives an UDP segment, it checks the destination port number in the segment and then direct the segment to the socket carrying that port number. And that's pretty much it. Okay? Now, of course, the IP address is important because the host at the network layer would be able to decide, whether this particular host is the destination of this packet, therefore keeping the packet and pass it up to the transport layer. And the transport layer could handle this. Yeah, receiving a UDP segment, check the port number, and so on and so forth. All right. So datagrams with different source IP address and different source port numbers, as long as they come to the same IP address, same destination port number, they will be going through the same socket. Okay. So demultiplexing for UDP is slightly simpler. All we care about is the destination address and port number. So here's an example of connectionless demux. So port 9157 is where P3 is sitting on. So that's one of the clients. Port 5775 is process P4 that is sitting on. So that's another client. Server in the middle, open up a port number 642A, and P1 there is the server processing. It's waiting for requests to come in. So we see here a service request message being generated from P3 and intended for P1. You will see source port number being 9157 and the destination port number being the server's port number 642A. And the return messages, so replies from the server would then be carrying the source port number being the server's port number and the destination port number being the sender's port number, the original request sender's port number, 9157, the client's port number. So you see also a little bit that how P1 can generate the reply. The port numbers are essentially the reverse, okay, of the requests. Now, if there's another request coming from P4, what is going to be the source port number? Yep, 5775. And destination? Yeah, the server's port number. And it's probably not hard. Yeah, the returning messages back to P4, source being 642A, essentially the reverse of these two port numbers. The slightly more complicated one is the connection-oriented demux. That is also the TCP's demultiplexer. So whether a packet or a segment should go to a particular socket depends on all four information. All right, so receiver uses all four values to direct the segment to the socket. Now, a server process running there on the host could be maintaining multiple sockets, okay, for each pair of communication per client. So for example, a web server, the web processes there could have multiple sockets open for each of the connecting client. And if this is older form of HTTP the web server is running, it could be one socket per object request. Now let me use an example to illustrate and explain. So we have a scenario where we have three segments being sent from clients over here, A and C, to the server in the middle, B. So all three segments destined to B, and they're supposed to be demuxed into different sockets. Now, P4 sockets will be using a four tuple to decide. And what will be the four tuple? Well, source IP address, A, destination IP address, B, and what? Source port number and the destination port number. So these four values is going to be associated with this socket. So when there's a segment arriving at the transport layer, matching the four tuple, therefore going to the socket. Similarly, for each of the sockets here and there, the 4 tuples will be stored, and the transport layer looking at the packet header when there's a match. Pass it up to socket to the processes. So that's the idea behind connection-oriented demux. And the reason it's called the connection-oriented demux is because it's not only looking at the destination, it cares also who the sources is. So it's almost like there's a one connection between the source and destination already, okay, the socket. Now, this connection-oriented demux socket is a little bit weird. And this actually happens quite often these days when we're doing this threaded server. Okay, so in your PA4, you are implementing a server, all right. What happened there is that you are starting a listening socket, isn't it? Listening socket is a little bit special because no matter where the client is, whatever the source IP is, request coming in is gonna be passed to that server socket, that listening socket, all right. Even though, the 4 tuple does not quite match, especially the source IP address and the port number. Okay. This type of connection-oriented demux, it is TCP, all right, but it only looks at the destination port number and the destination IP address. Therefore, the message is coming out this way. Source being A, source port number 9157. This one here, source being C, port number again different. But then they will all be accepted by the listening socket here.